Okay, now we are moving on to the next question of our textbook, exercise 6B, book 3, 7th edition. And question number 3, I am not going to write the question, it's a very long question. There are two parts in this question, I'll do one of them. Given that the coordinates of the points P and Q are respectively -2,6 and 9,3. This is question number 3 that I am discussing. 2 points are given. P and Q. P is -2,6 and Q is 9,3. These are the 2 points given. In part A, they are asking you to find out the coordinates of the point R. There is another point R that lies on the y-axis such that PR is equals to QR. So, in this case, they have given you 2 points which are completely known. Then they are saying there is another point R which is lying on the axis of Y. Since it's an unknown point right now, I can just write for the time being that R is x comma y. For instance, that unknown point is x comma y. And then they have asked you to find the value of R. In order to find the value of R that I have assumed right now, I have to find the value of x and the value of y. These are two variables, so I require two equations. The question will give me something to form an equation. The question has clearly mentioned that there is a point P, there is a point Q, there is a point R on y-axis, and you have to find out the value of R when PR is equals to QR. You can use this relation to form just one equation. So, if you are just given one condition to form an equation, you cannot find the value of R if it contains two variables. So, there comes a very important instruction. The question has clearly mentioned that R lies on y-axis. Any point that is lying on the axis of y will have its x component equals to 0, and any point that is lying on x-axis will have its y component equals to 0. I hope you know that. So when I assume R, knowing that R lies on y-axis, I know that this value is definitely 0. So now I have 3 points involving one variable and I have one condition to form the equation PR equals to QR. PR is the distance from P to R, QR is the distance from Q to R. I can use distance formula to find PR, I can use distance formula to find QR. They both will be in terms of y. I can put them together equal to each other, form an equation and then solve it. Have a look. PR, let's say this is x1, y1. This is x2, y2 in case of PR. So, if I just substitute in the value x2 minus x1 becomes 0 minus 2. It doesn't matter if you take this is x2 comma y2 and this as x1 comma y1. Doesn't really matter. x2 minus x1 is square plus y2 minus y1 square, y minus 6 square. This is PR. I know PR is equals to QR. Now when it comes to QR, let me take this as x2 y2, this is x1 y1 in case of QR. So x2 minus x1 is 9 minus 0 square plus y2 minus y1 is 3 minus y square, and they both are inside the square root. In order to get rid of the square root, I square on both sides. When I square on both sides, the squares on both the sides will cancel. I only have this remaining with square root removed. Minus minus becomes plus, 0 plus 2 is 2. So I am left with 2 square plus y minus 6 square is y square minus 12y plus 36 is equal to 9 minus 0 square is 9 and 9 square becomes 81 plus 3 minus y whole square will be expanded using a minus b whole square. 9 minus 6y plus y square. Those roots that they were there, I have got rid of them by squaring on both the sides. I hope you are listening. 2 square becomes 4 plus y square minus 12y plus 36 is equals to, let me rearrange this, y square minus 6y, 81 plus 9 becomes 90. Okay, in order to solve this equation, I'll bring everything on this side. Y square, this y square comes on this side, becomes minus y square. Minus 12y and minus 6y comes over here, becomes plus 6y. Plus 4 plus 36 is plus 40. And when that 90 moves over here, it becomes minus 90 is equals to 0. I can cancel these y squares. I would have cancelled them over there as well, but I did not do that. Minus 12y plus 6y is minus 6y minus plus 40 minus 90 becomes minus 50 is equals to 0. In order to find the value of y, I'll take that 50 over there, minus 50 goes over there, becomes plus 50, and then minus 6 which was remaining over here, I'll move that to the other side. It will divide 50 and it will become 50 over 6 negative. 50 over 6 can be simplified and becomes 25 over 3. This is the value of y. So when I have the value of y, now I can tell the value of r completely. The value of r is going to be 0 comma y. 0 will remain 0. So r 0 comma y is now equals to 0 comma minus 25 over 3. This now is the value of r. Following this pattern, you can solve part B of this question. That will give you 2 points. There will be an unknown point which will be lying on the axis of x. In that case, you will assume that point to be x comma 0. When a point lies on the axis of x, then the y component is 0 in that case. Following the same method, you will form the equation and solve for the unknown, and then eventually in the end you will find the value of the whole point using the same way. Thanks a lot.